All right, guys, question number 4. But before we answer the 3 questions below, I first want to analyze the diagram because this diagram is very important when it's going to come to your exams. There'll be questions with cards on your exam. However, the diagram will not be available to you. So we're going to analyze it, and I want you guys to become comfortable with cards. Here is a table showing all 52 cards in a standard deck. Now, if you look at these deck of cards, right, there are 2 colors. My 2 colors are red. Red. And I have black. Now, there are 52 cards in the deck. Half of them are red, half of them are black, which means I have 26 red cards and 26 black cards. If you also notice, I have 4 different shapes, and these shapes are called suits. The first shape is called hearts. And I'm going to box that in blue. The next one is called diamonds. Diamonds. The third one is called spades. And the last one we call clubs. Some people call them clovers, but we call them clubs. Each color has 2 different suits. Each color has 26 cards, which means if there are 26 cards in each color, and each color has 2 suits, that means each suit will have half of 26, which is 13 cards. There are 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Look at the top. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, and king. These are the different values. These are the different values my cards can assume. Each value has 4 cards. And if you can count, there are 13 values. So 4 values. So 13 values times 4 cards in each gives me 52. Each card has 4 values. And before I end the analysis, I want to focus on one more thing. And that's going to be the last 3 cards in my columns, the last 3 values. And it's called Jack, Queen, and King. And we call these face cards. And the reason we call these face cards is because when you play with a deck of cards, each of these values will have a face on it. There are 4 queens, 4 kings, and 4 jacks, which means there's a total of 12 face cards. So, this is how you need to analyze your deck of cards and become comfortable with the deck of cards because they will appear in multiple homework assignments, in class questions, and at the same time on exams. Now, with that said, we can answer the following questions. Suppose one card is drawn at random from a standard deck. What is the probability the card drawn is a face card? So out of 52 cards, we just established that there are 12 face cards. So the probability of having a face card is 12 out of 52. Remember, you must reduce your fraction. Both 12 and 52 are divisible by 4. 12 divided by 4 is 3. 52 divided by 4 is 13. The probability of selecting a face card is 3 over 13. In its regular form, 12 face cards out of 52 cards. Now, the next one says, what is the probability of drawing a diamond? We already established that there are 13 diamonds in my deck of cards. So the probability of selecting a diamond is going to be 13 out of 52. And yes, in this case, you must reduce this fraction. And because both 13 and 52 are divisible by 13. So divide 13 from the top and 13 from the bottom. 13 divided by 13 is 1. 52 divided by 13 is 4. That is 1/4. And that makes sense because diamonds is one suit out of 4 total suits. Thus 1/4 in its reduced form. This next one, I want you guys to be careful how you approach it. Because it says, what is the probability the card selected is a face card or a diamond? Now, the tendency that students usually do is add the number of face cards and the number of diamonds in a deck. However, do not make that mistake. Do not add 12 face cards and 13 diamonds and get the answer of 25 and put that as 25 over 52. Because if you do that, you're going to have an issue because you'll be counting a certain number of cards twice. Now, it can be either a face card or a diamond. So let's go back up to the picture. Highlight all the face cards. Highlight all the diamonds. Or gives us options. Or means union. So gotta have one or the other. And let's count that off. We know off the bat there are 12 face cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But if you noticed already, I already counted 3 diamonds. The Jack of Diamonds, the Queen of Diamonds, and the King of Diamonds. So when I count my diamonds, you do not count the Jack, Queen, and King of Diamonds again. They've been counted one time. Do not double count. So far, we are at 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. There are 22 cards that can either be a face card or a diamond. So the probability of having a face card or a diamond is going to be 22 out of 52. And we can reduce 22 out of 52 by dividing the numerator and denominator by 2 because both are even numbers. 22 divided by 2 is 11. 52 divided by 2 is 26. So I hope you understand how to analyze our card sample space. And I hope you understand how to answer the questions below and to look at the third option. And the word or means to combine both together to make one overall, but do not double count. All right, guys, that is it for this video. Hope this made sense. Hope you enjoyed it. I'll see you soon.